Example 2. Determine A5 and AN for the geometric sequence 6400, 1600, 400, 100, and so on. All right, so we need to find a specific term here, the fifth term, and we also need to write down a formula for the nth term of the geometric sequence. Okay, we're going to start by verifying that this is indeed a geometric sequence. Okay, I'm going to try to examine how I go from one term to the next. Notice that the numbers are going down here, so I'm just going to plug into the formula here. To come up with the common ratio, I just need to pick a term and divide by the one that comes before it. So I'll pick 1600, the second term, and then divide by the first term, 6400. If I pop this into the calculator, we're going to get that this R value is going to be 0.25, which is 1/4. Okay. All right, so the common ratio here is 1/4. So we can see that to go from 6400 to 1600, we need to multiply by 1/4. And then if we take 1600 and multiply by 1/4, we do get 400. And to go from 400 to 100, we have to multiply by 1/4. So that trend is holding. Okay, so this is indeed geometric with a common ratio of 1/4. Okay, all right, we are going to start here I'm actually going to start by getting A5. Okay, why? Well, it's easy to do. We know the first four terms, and I know the common ratio. So to get A5, I just need to take A4, where I left off in the sequence, and multiply by the common ratio. Okay, so to get A5, I'm going to take 100, the fourth term, and multiply by the common ratio, which is 1/4, and that should give me 25. This is the same thing as 100 divided by 4. Okay, so the fifth term here is going to be 25. Okay, so that's pretty straightforward. Now I will try to come up with a term, or sorry, with a formula for the nth term of the sequence. Okay, we want to be able to plug in and have spit out the nth term of the sequence. Okay, all right, this is geometric, so we just learned that the nth term of the sequence is going to be given by this formula at the bottom of page 2. AN is going to be equal to A1 times R to the n minus 1 power. So let's go write that down. So AN is equal to A1 times R raised to the n minus 1 power. Okay, we're coming up with a formula for AN. Okay, so n is going to stay in. We want to be able to plug in an n value, like I said, and the output will be the nth term. Okay, so we need to plug in the value for A1 and also for R, and then AN and N will stay as they are. Okay, so luckily we already know A1, we know R, so we can just plug everything in. Okay, A1 is the first term of this sequence, so A1 is 6400. Okay, so we can go ahead and plug that in. 6400 times the R value is 1/4, and we're going to raise that to the n minus 1 power. Okay, that's the formula. That's it. Okay, you cannot simplify this. Remember, the 1/4 is raised to a power, so you cannot, for example, multiply the 6400 through to the 1/4. You can't do that, okay, because of the power. All right, so that's all we have to do. 6400, 1/4, 6400 times 1/4 to the n minus 1 power. That's the formula, okay? If you want to do a check, you can. It's not necessary, but say you wanted to make sure this is working correctly, let's check it for the third term. So n would be 3. You would pop n equals 3 into our formula. So A3 would be 6400 times 1/4 to the 3 minus 1 power. So if you plug this into the calculator, 6400 times 1/4 to the 3 minus 1 power, that's the second power, okay, and you do get 400 as expected. Okay, so we know we're right. Okay, all right, let's try example 3. Okay, example 3 says determine R and A1 for the geometric sequence having A2 is equal to -18 and A5 is equal to 486. Okay, as you can see here, I have a couple of methods listed here, so I'm going to try to work this more than one way just to give you some options, and you pick the way that you like best. All right, so we have a geometric sequence. All we know about it is the value of the second term and the value of the fifth term, and we are tasked with finding the common ratio and the value of the first term. Okay. All right, so here's what I'm going to do first. Okay, we are going to use the information we know, so the information about A2 and A5. Okay, so I know so far the only formula I know about a geometric sequence really is that if I want the nth term, it's equal to A1 times the common ratio raised to the n minus 1 power. Okay, I am going to apply this formula to both A2 and A5. Okay, so I'm going to start with the second term here. Okay, so if n is 2, replace n with 2 everywhere in the formula. So we're going to get that A2 is equal to A1 times r raised to the 2 minus 1 power. Okay, that tells me that A2 is A1 times r. Okay, so I know that A2 is negative 18. So I'm going to plug that in. Okay, so this tells me that negative 18 is equal to A1 times r. Okay, that's as far as I can go. I don't know A1, that's what one of the things I'm looking for. Okay, and I don't know r. I'm looking for it as well. Okay, so let's continue. What can we do now? Well, I can also apply this generic formula. Okay, this guy right here in the box. Okay, I can apply it to A5. Okay, so now if n equals 5, we get that A5 is equal to A1 times r to the 5 minus 1 power. Okay, so if we simplify, this tells us that A5 is equal to A1 times times r to the 4th power. Okay, and we're going to plug in what we know. We know that A5 is 486. So we come to the conclusion that 486 is equal to A1 times r to the 4th. Okay, so we've come up with this, and we've come up with this. Okay, I still don't have a value for A1 or for r. Okay, both of these equations in the boxes here, both involve A1, both involve r. Okay, so what can I do? Okay, because I need both of those values. Okay, so if you notice, both of them, like I said, both involve A1 and involve r. How can I manipulate them to get what I want? Well, I can't set them equal to each other. Okay, the right side of this equation is A1 times r. That's not the same thing as what I have on the right side of this equation. So there's not going to be any kind of equating involved. But what I'm going to do here is divide them. Okay, I am going to start with this box. Okay, I'm going to write the right side here, A1 times r to the 4th. Okay, I'm going to divide it by the right side of this guy. Okay, divided by A1 times r. Okay, that's got to equal A1 times r to the 4th is the same thing as 486 over A1 times r is negative 18. I'm basically making a ratio. Okay, this is how I'm going to manipulate these two things in the boxes. Okay, all right, why am I doing this? Because look what this does for me. On the left side, the A1s cancel. Okay, and so then I have r to the 4th, which is r times r times r times r, divided by r. So an r cancels in the top with one in the bottom. This is going to leave me with r cubed is equal to 486 divided by negative 18, which is 27. Okay, negative 27. Okay, so this can be solved for r. Okay, all I have to do now is take the cubed root of both sides. Okay, so I'm going to go ahead and take the cubed root of both sides to undo the cube. Okay, and this is going to tell me that my r value has got to be negative 3 because the cubed root of negative 27 is negative 3. Okay, so there's your r value. Okay, that's your common ratio. All right, so now that we have r, we should be able to get A1. Okay, I'm going to return to my boxes. Okay, I'm just going to pick one of the boxes and plug in the r value to solve for the A1 value. Okay, so I'll just use this box because the exponent's just to the first power. So I'm going to get that negative 18 is equal to a1, that's what I'm looking for, times r. R is negative 3. Okay, I've got to divide both sides by negative 3. Okay, and then the negative 3's will cancel. I'm going to get that a1 is equal to positive 6. Okay, so there's your answers. Okay, the first term in this geometric sequence is the first term is 6. Okay, and then you'll use the common ratio of negative 3 to generate future terms. Okay, and you can kind of check yourself here. If you do a1 times r, you're going to get negative 18, which is the second term. Okay. All right, another way I could have done this problem, okay, again, if you just start from scratch, reread the problem, know you're trying to calculate R in A1, given A2 and A5 information, you could have done this, okay? Think about how A2 and A5 are related, okay? If I start with A2 and I multiply it by R, that's going to give me A3, okay? And then if I multiply by R again, that's going to give me A4. And then if I multiply by R again, that's going to give me A5. So we could have thought about it this way and realized that A5, to get A5, you need to take A2 and multiply by R to the third power. Okay, so in general, what I'm doing here, okay, is if I'm looking at AN, okay, that is the same thing as AM, a different term, times R to the N minus M power. Okay, so notice, if I'm looking at the relationship between A2 and A5, okay, the future term A5 is equal to the prior term times R raised to what power? Well, you just subtract M from N. Okay, so that's another way we could have done this. Okay, if you thought about it this way, then you could go straight into plugging in A5 and A2. I could have just said, okay, A5 is 486, A2 is negative 18, and from the get-go, you would be able to get the R value. Okay, so you would just divide both sides by negative 18 here. Okay, you go to the calculator. We know that that's negative 27. Okay, and then do what we did in method 1. The R value would be negative 3 if you took the cube root of both sides. Okay, and then again, once you have R, you can calculate A1. Okay, I guess it's a little bit different here because, all right, let's say if we did go this way. Okay, if we went method 2 and we did all this work and we got R equals negative 3, how would you go about getting A1 after you find R? Okay, well, you don't have those two boxes to rely on, okay, that I used in method 1. What you would do at this point is once you have the R value, I would go back and use the fact that AN is equal to A1 times R to the N minus 1 power. And then I would plug in negative 3 for R, okay, and I would use N equals 2 because I know information about the second term. Okay, so plug in N equals 2. Okay, so that's going to tell you A2 is equal to A1 times negative 3 raised to the 2 minus 1 power. Okay, and we know A2 is negative 18. Okay, and then the exponent on negative 3 will be the first power. And so then you get negative 18 is equal to A1 times negative 3. Divide both sides by negative 3, and you get that the first term is 6. Okay, so this was another method for doing this problem. This is key, okay? Recognizing that if you start with a term, the mth term, okay, you can get to the nth term, a future term, by multiplying the mth term by N minus M times, okay? That is key, okay? And at the top of page 4, I have this alternate formula for the nth term of a geometric sequence summarized. Okay, so again, it says in a geometric sequence with mth term am and common ratio r, the nth term an is given by the following. An is equal to am times the common ratio r raised to the n minus m power. Okay, and again, this is just coming from what we saw in method 2. Like if I started with A2 and I wanted to get to A5, I had to multiply once to get A3, again to get A4, and then another time to get A5. Okay, and so if this is your AN and this is your AM, okay, to come up with AN, the nth term, which comes after the mth term, you would take the mth term and multiply it by the common ratio raised to the n minus m power, okay? You're getting A5 here is A2 times r raised to the 5 minus 2 power, okay? This is another handy formula to know for geometric sequences.